those of you who want to answer the questions, you can type in the chat box your answers. Okay. And also, like Kavya introduced, I am a science educator and I've been a science communicator. So those of you what a science communicator does, so I try to take science to public at large. I write blogs, I make videos, trying to simplify science and try to take it to a larger set of people. So that is I communicate science. I also have huge interests. Okay, my audio is not that clear. Kavya, am I audible enough?
Yeah, you're audible. You're loud and clear for me.
Okay, right, good, thanks. So I have huge interest in astronomy. I've been into astronomy for the last 7 8 years, where I also am aspiring to be an astrophotographer. And my favorite subjects are physics and mathematics, and the same subjects that I told you now, I teach students also. So that's a little about me. So the topic for today is science versus technology. I deliberately put the title to be science versus technology. But that is not how I'm going to position or talk about the subject today. I'm assuming that you guys are not clear about what is science and what is technology. So I'm going to take this session in three parts. The flow of the session will be in three parts. One is science versus technology, and second part is what is the difference between them, and what I mean when I say difference between them. Okay, my voice is breaking a lot. I think I have to sit closer to the Wi-Fi router. Maybe my internet. Okay, so I think a lot of you are saying the same problem, which I assume has to be true. Uh, just give me a moment. Let me check my Wi-Fi router. Geo extenders. Okay. Am I better? Because is it good now? I guess not. Yeah, I'm not sure about my. I don't know how louder I can get. I'm on, but I think I'll try to shout. I'm shouting on top of my lungs, but I'll try to maintain it. I'm keeping my microphone very close to my mouth as well. I don't know how better else I can do. Yeah. So now, like I told you, I'm going to take the session in three parts. One is understanding what is science, what is technology. The second part is the difference between them, like in a little more detail. What is the difference between them? And finally, how in real life or the things around you, science and technology plays a role. Okay. I would like to start by a very famous quote by a very famous astrophysicist. He's no more, but I'm sure some of you may know him already. His name is Dr. Carl Sagan. So, do you guys know him? I think some of you will definitely know him because some of you are from my astronomy club as well. So, Dr. Carl Sagan, any of you read his books or know him? Okay, only Uday knows. None of you others have heard of Carl Sagan. You can type in the chat box. Yes, some of you know him already. So Dr. Carl Sagan has a very famous saying that when in one of his books, I've read a lot of his books. In one of his books, he says, I think the name of the book is uh, Brokaw's Brain. Maybe I'll refer the link to the book later after the session is done. But the quote is this: We live in a society that primarily depends on science and technology, but despite its significance in our society, hardly anybody in the society knows about it, knows about science and technology. So now this is, look, this book was written in 1991 or 1992, more than 28 or 27 years ago. He talked about when he meant society, he meant the United States, because he was a American scientist. So he was referring to United States society back then in 1990s, how the public was not interested in science and technology, how public did not know about science and technology. But the same remains true for the entire world, though he may have said it from an American perspective. But the quote that he says is relevant to the entire world, barring few countries which have a lot of focus on science and technology. But in our country, even today, 28 years after the quote has been said, it is still true today. I'm not talking about you guys. Maybe you learn a bit of science in your school, bit of technology that you use, whether it's a laptop that you are using to listen to this right now, or the technology Zoom as a platform that we're trying to use. So maybe you guys are not so much dissociated from science and technology, but the population at large, they're not interested in science and technology, but without their knowledge they're dependent on it. So now here's the thing. Now the question to you begins: what do you think is science and what do you think is technology? Can you type it out, or if you want to talk about it, you raise your hand. I'll give you the permission to unmute, and then you can talk. What do you think is science and what do you think is technology? You guys can tell. None of you are raising your hands. None of you want to talk. Jayant, yes, Jayant, you can say.
Sir, I think uh, science is something that we learn what is all around us, and science technology is dependent on science, and technology is something uh, that has network, all those things.
Okay, then that's a good one. Would anyone else like to get an answer? Thank you, Jayant. Yes. Anybody else? I don't see any other hands going up. That is just sad. There are 18 of you. Science is everything. Then what is technology, Miru? Miru says science is everything. Then what is technology? No one else wants to take. I mean, okay, um, it could be one of these two reasons. Either that you do not know it, or you know it and you don't want to say it. What is it? You guys do not know it? Someone you are raising your hand. Okay, someone you want to say, you can say.
Nah, science is what we use. Science
I'm unable to hear you.
is
Someone can you
something
repeat that?
around us that we use, what we need, and that is called technology.
Okay, okay, good one, good one, correct. Thank you, Samanya. Anybody else? Ayman, you had some question. What is the question? You have some question. Can you type it out, or is it an answer you want to give? You and Akshay, none of you want to give an answer? Bharat, Ram, I can see a lot of names. Uday. Okay, science is used in our everyday life. Okay, then Vinesh is technology application of scientific knowledge for practical purposes, especially in industry. Good one, Vinesh. Vinesh, you can type your answer in the everyone chat box, not to me privately. So you can type it so that everybody can see. Science is the base of everything. In that science, technology is also involved. I'm seeing a lot of answers. Yes, yes. Go ahead. Someone wants to talk?
Anna, can I?
Yes, yes, please.
So, science and technology both are integrated now because in periodic table, you want to find a new thing, you need particle accelerator. So, that is also technology. And with science only, you're making technology. Like science is integrated with mechanism and everything. So, with that only, you can create any robots or anything. Like everything is integrated.
Okay, good one, Uday. Anybody else? Good. I think all of you are getting there. I'm just gonna look. I'm not gonna give an entirely different answer from what you said, but I'm gonna just add more clarity to your thoughts. That's all. But before that, anybody else wants to go? So the newcomers, let's try. Alicia, Yuvan, yes, Yuvan, you can try.
Uh, so, science is everywhere, but we don't know it. We are using it every time. From something
as simple as you as simple as cooking to something to live to us living.
Okay. Okay, good. Then
we
technology.
are we are using it right now it's as technology.
Okay. Okay. I get it, Yuvan. You're right there. Good. Correct. Thank you, Yuvan. Anybody else? The newcomers, I think I have Alicia. Uh, I don't know. Anybody else? Simon, he's replied. Jayant has said. Jonathan Franklin. Science and technologies interconnected. Okay, enough. I think I've given you enough. And okay, the answers that you've given is correct. But now I'm going to add a little more clarity to it by telling you a interesting story from history. Okay, so how many of you know this scientist named Michael Faraday? How many of you know Michael Faraday? You can type in the chat box if you know him. None of you know Michael Faraday? That is just sad. Okay, Jonathan says technology often used with science to boost it. Okay, so some of you know Michael Faraday and some of you do not know him. Okay, now the next question. Those of you who know Michael Faraday, what is Michael Faraday famous for? What did Michael Faraday do? What is he famous for? What is Michael Faraday known for? Okay, anybody? What is he famous for? What do you think of when you think of his name? Electromagnetism, a scientist. Invention of electric motor. Interesting answers. Okay, good. I'll give it to you guys. So, Michael Faraday was very famously known for his uh, understanding of electricity and magnetism. So now, today we know electromagnets exist. Now we can create a magnet just by using the idea of electricity. By passing electricity, we can create magnets. We know that today. But back in the early 18th century, like 1750s or 1760s, people did not know that electricity and magnetism were somewhat connected. So we people thought of it to be different. So they thought electricity. So that was the time where scientists were working on chemical batteries. So now remember the batteries that you use for your mobile phones or batteries that you use for your remote controls, they are called DC batteries. Okay, so DC batteries are batteries where the electricity will be stored, energy will be stored inside the battery, and when you connect wires you can consume that electricity, so that you call them DC batteries. So that was a time back where electricity was being discussed. You guys may have heard of Benjamin Franklin, the guy who studied about electrical charges. Also the very famous, yeah, lithium batteries, yes. So there is this very famous uh, uh, terminology that you may know already. Volt. Have you heard of this volts? 1.5 volt battery, 2.5 volt battery, lithium ion batteries, or maybe 4 volt batteries. So the volt name comes from a scientist. His name was Volta, Alexandra Volta. So he was experimenting in the early 18th century, late 17th century about batteries, chemical batteries. Back then, the batteries used to be very huge, like huge cylinders filled with chemicals and very big wires connecting them. Today, we have very small compact batteries, but when it was first done, it was huge cylinders filled with chemicals, and they were trying to study about how electricity worked. But little did they know that electricity was even remotely related to magnets. Magnets were known even before electricity. Do you know why? Do you know why magnetism was known even before electricity? Something called as lodestone. So magnets were found in a natural environment in the form of lodestones. So they found these stones that could attract some iron particles or some particles that were electromagnetic. So magnets were always found naturally on the earth. But despite that, people did not, even the scientists who were working back then had no idea that magnets and electricity were related to in some way. So now there was, during this experiment. So it was not just Alexandra Volta who was working on batteries. There were so many other scientists working on batteries. So one of the scientists who, when he was working on batteries and trying to pass current through a wire, there was a magnetic compass. Okay, all of you know what is a magnetic compass, right? So there was a magnetic compass that was lying close to this wire, through which they were conducting an electricity based experiment. And these guys, along with Michael Faraday, who was an assistant to this scientist, saw that each time the current passed through the wire, then the magnet moved. The magnetic compass, the needle in the magnetic compass moved, changed its orientation. When the current was switched off, the batteries were switched off, the magnet stopped moving. When the battery was turned on, the magnet moved. So this was puzzling back then. How come that the magnetic compass and the wire were not physically touching each other? They were kept apart. There was quite some distance between them. But despite that fact, the something that is going through the wire seemed to disturb something that was on inside a magnetic compass. There's a magnetic needle. That was puzzling. So that was the moment which got Michael Faraday started wondering, what is this? Is there something invisible that is moving out of the wire and touching the magnetic needle inside? People were puzzled it, and that was the beginning of a journey of the most famous scientist that we all know. Most famous scientist, I would rather say the most famous experimentalist. Okay, look, Michael Faraday was not a very great scientist, meaning he did not understand mathematics, for example. He was very weak in mathematics. He did not go to formal school to study science as a subject. Again, he did it with a great difficulty. So he was not by any formal definition a great scientist. But informally, he was very curious in his mind. He wanted to know what was happening between the wire and magnet. So he wanted to understand the nature. Okay, he wanted to understand the nature of the electricity and what is the nature of magnet. Now this curiosity, understanding what is going on, so nature seemed to have a mystery. There is a mystery in nature, and you want to know what is going on, and that curiosity and your attempt in finding it is what we call as science. This is an example that I'm giving you what science is about. You try to understand some fundamental nature of nature itself. What is going on in the nature? What is going on inside this little magnet? What is going on inside that wire? And what is going on inside the wire is how is it affecting what is going on inside the magnet? So these curiosities about nature, when you try to answer them and when you find answers, that you call it as science. Now let's come to technology. But before let's coming to technology, let us understand this story a little more. Okay. Now Michael Faraday was working on this understanding, and it took a lot of years. It probably took 5 to 10 years for him to come to a proper understanding of how magnetism and electricity were related. Okay. So now with that, he was able to demonstrate. Okay. So any scientist, okay, look, what do you need to be? One of the most important things that you need to become a scientist or do the experiments that you want: money. Okay, someone has to give you money to keep doing what you want to do, right? So who is going to pay you money? Michael Faraday was not a rich person. He was working part-time to even support his own school education, so he was not a very rich person. So for any experiment to do, you need money. And who is going to give you money? Today we have governments. We have the government, central government, who will allocate some funds for science research. But back then in the 18th century, early 18th century, who do you think will give the money? The kings of the time, or maybe the church of the time, or the state. So there are some people in power back then who would give. Maybe the queen will allocate funds. Okay, Michael Faraday, your experiment seems to be good. I can give you the money. You can go ahead and go. So without this funding money, Michael Faraday could not have continued with the experiment on electricity and magnetism. Now, whenever you are asking for money, you have to prove something to the authority that what you're doing is worth doing. Correct. So when you're doing something, so the government or the people in power have to be convinced that what you're experimenting on is worth giving you money for. Okay. So now in that sense, Michael Faraday had to do a lot of demonstrations to the people in power. Look, what I'm doing is so beautiful. Look, come to my lab and see what I'm doing, and then you can decide for yourself whether it is worth investing in it or not. So now Michael Faraday, after his invention of, or the discovery rather, in discovery of the connection between electricity and magnetism, he invites the people in power, the queen and all the other people, to look at what he has done. So what he demonstrated is basically this. So what he did was, he had a magnet, okay? He had a magnet placed in the middle of a cylindrical bowl, and that bowl was filled with some chemical, and he tried to pass current, okay, current through the wire. The magnet was placed, and he had a wire that is going into the bowl touching some chemical. So now he passed current through the wire. You know what happened? The wire started moving around the magnet. This is a very, very important discovery in the entire human race. He passed current through the wire with a static magnet. When I say static magnet, the magnet is not moving, it is fixed inside a bowl. And by passing a current through the wire started moving around the magnet. When the current was turned off, the wire stopped moving. But when the current was turned on, the wire started moving around the magnet. So to those of you who are wondering what this is the beginning of an electric motor. This is the beginning of something. Look, right now when you're listening to this lecture, the fan above you works on this principle that Michael Faraday was demonstrating on that day, or the mixie that you have in your home. Anything that spins, right from the windmills or to the turbines that they use in dams to generate hydroelectric power, anything that you see around you that spins uses this scientific principle. You have a magnet and you have a wire that carries current. With these two things that Michael Faraday was demonstrating way back in early 18th century is what our entire surrounding depends on. Now he was demonstrating this back. Oh, let's get back to the story. So now he was demonstrating this to a well, like, a position, a people in power and people in position. He was demonstrating this, and he was saying, look how beautiful the wire moves around the magnet. Now everybody appreciated it, everybody clapping, and everybody was happy about what was Michael Faraday doing about it. But despite the fact that a lot of people loved what Michael Faraday demonstrated, there is another important person. I forgot his name. Maybe the name was never recorded. He goes to Michael Faraday and asks this very famous question to him. Look, Michael Faraday, what you've demonstrated to us is superb. It's awesome. For those of you who do not understand, it almost looks like magic. It looks like magic. It is still a mystery to us how we are able to make the wire move around the magnet. We don't understand it. It's amazing. But with what you demonstrated to us, of what use it is? Look, this is beautiful to watch, but why should we even be experimenting on this? Is it to invite people to a public lecture and make them, clap their hands and entertain them? Is it all about entertainment that you want to show something like this is possible? Of what use is your demonstration? Now, this is a very famous question that has been recorded, and the response by Michael Faraday is even more astonishing. Okay, now he asks the guy who asked the question back, sir, what use do you think is a newborn baby? So now you have a baby who's born, who's just come out into this world, who's just 1 day old, and what use do you think that baby is of? And to that guy got like shocked. Of course, we do not know what this baby is. It depends on who grooms him, who is the mother, who is the father, and what are the interests of the child. The child can grow out to be another famous scientist or another famous person who is able to discover things or invent things that could be of use to people, or it could be a very famous sports person, or it could be the baby could turn out to be a very famous musician. We do not know simply what that baby is of. Now, Michael Faraday asks again, very well then, the concept that I've demonstrated right in front of your eyes, I do not know. It is just like a newborn baby. Only time can tell what this simple concept, making a wire move around the magnet, could be of use to people. Only time can tell. But today we know our society primarily depends on that one piece of a scientific principle. And remember that one understanding of nature has benefited us in multiple ways, like be it the fan or the mixie or the thermal power station or the hydroelectric power station or nuclear power plant or the windmills. anything that spins, or your generators that you have at home, whatever it is, that depends on that. So now that scientific principle is being converted into a machine. It's being converted into a machine that can benefit humans or others. And that is what is technology. So now, do you guys understand this? What technology means? And the technology may not even be realized at the time of the scientific discovery. Okay, at the time of you make a scientific discovery, the technology that might be of use using that concept may not be even existing in that century. In fact, it was long after Michael Faraday was dead that people actually started realizing the potential of his discovery to make it beneficial to a lot of people. I can tell you another example, okay, with relevance to the current context. How many of you know that there are some concepts or some discoveries being tried to be made? Like, for example, I do not know what to say, maybe neutrinos. How many of you know neutrinos? Any of you heard of this word neutrinos? Okay, neutrinos are nothing but they're very tiny particles. So look, like just like how we have atoms, and within atoms you have electrons, protons, and neutrons. There are a lot of particles, not just these three particles. There are hundreds of particles, and one of those particles is neutrinos. Okay, and until about maybe a few decades ago, people did not even know that neutrinos exist in reality. Okay, so now people have started detecting neutrinos, and they're detecting neutrinos from the sun, and they're detecting trillions and trillions of neutrinos they know are existing coming out of the sun. Now there are huge laboratories, okay, there are huge experiments in the world where their only job is to find neutrinos, okay, and understand what are neutrinos, understand what is the character of a neutrino, understand what is the nature of a neutrino. Now the question is like, what are we doing that for? Why do we even have to study about neutrinos? Of what use it is? What is the big deal if you understood neutrinos? Nobody knows. Nobody knows what is the use of a neutrino. Maybe 50 years down the line or 100 years down the line, our communication technology may primarily depend on neutrinos. We do not know. So now, does it mean should we invest in neutrinos or should we not invest in neutrinos? So what do you guys think? Should we invest in neutrinos or not invest in studying neutrinos? Yes, it may be useful in future, but may not be useful to us right now. But if the same thought if Michael Faraday had, or the people who funded him, why should we fund Michael Faraday? Because it's of no use today. We wouldn't be having this comfortable space where we're talking to each other. So now this is the essential difference between science and technology. Science is always about understanding nature, understanding new elements of nature, what is going on in nature. So can we find some unknown mysteries? Can we solve something that is not known to the world? And there are another set of people who will pick up these scientific discoveries, several scientists, and their only job is to see, oh, this science is there. Now, what can we use it for? Can we apply that science so that it is beneficial for humans or other species or anybody? So that applied science is what we call as technology. I hope I amply made it clear about what is science and what is technology, what's the difference between it. Uh, did you guys understand it? Understood it? If you guys understood it, please type in yes, what I was trying to say. Please try to, if you've understood what I want all of you to tell me so that I can move on. Okay, great. I assume that you guys have understood what I mean by science and technology. Now the question is this: is technology, science and technology, good or bad? Is science and technology good or bad? Some of you have some doubt. Yes, you can ask some of you. You've been raising a hand. Yes, I'll drink some water in the meantime.
So I have a doubt about the Michael Faraday. You told the wire is rotating the magnet. How could a wire, if it is in the fan, it has to rotate some strong metals around so it spins. How could a wire and that, you told that magnet is spinning. How can it happen?
Do you know there are magnets inside the fan? If you remove the coil and see, there is a powerful magnet. Did you know it? Next time when the electrician comes to your house, you ask him to remove the coil of the fan and things and show you. They have a huge magnet, very powerful magnet. And when the current passes through it, look, you need a magnet and a wire to spin things. The more, if your idea is to spin things, you need a magnet and wire. But how does it actually work? I'll maybe probably in another session I'll try to teach you somebody, because it's a little more technical, and you need to understand how what comes out of the magnet and things like that. But all the fans or anything that spins, it could be a mixie. If you remove the mixie and see, you will have an electromagnet. So anything that spins has a magnet inside. Without magnet, just by passing current, you cannot spin things. You need a magnet. Even the motor. Remember, for your science experiment, use the small motors. Small motors you have where you can connect your fan and spin. For science experiments, you will use. If you remove that also, you will see there are magnets inside. Have you observed? There are magnets inside. So without magnet and without current, you cannot spin things. All this thanks to Michael Faraday, just his curious mind, who was able to do this, and right now our entire civilization depends on it. Yes. Okay, now coming back to the question, do you think science or technology, is it good or bad? Now that is my question. So let's see if you can raise your hands, talk and answer. You don't have to type it. If you want to type, you can type, but you can answer by talking also. Jayant, yes, you can. Jayant, should I unmute you or something? Uh, where is Jayant? Okay. Yes, Jayant, you can. Next, I'll come to Bharat and then Samanyu.
Yes,
Jayant, you can talk.
technologies and science is a bit good and bad, we can say, sir, because good means for now we are connected to online.
I can hear you. I heard till connected online, Jayant. After that, I didn't hear. Bharat, I'll come to you first. I'll finish. Jayant, you figure out your network connection. In the meantime,
Yes,
you're
sir.
okay. You can talk, Jayant. Now.
It's a bit
Okay,
good
continue,
and bad
please.
because now we are
Okay, no problem, Jayant. You take couple of minutes. I'll come back to you, Bharat. Okay. Yeah. Bharat, yes, you can talk.
So, science and technology can be good and bad. So it can be good if it's used in a good way, like attending online classes, and is bad if used in a bad way. Example, gaming.
Gaming. Okay. So you're saying gaming is bad. That might disappoint a lot of people. Anyway, okay. Thank you, Bharat. You're right. So it depends on how you use it, correct? Who else wants to go? Jant, you, I don't know. I think Samanyu, you wanted to talk as well, right? Samanyu? Yes. Yes, Samanyu, and then.
Sure, if science is good, if we use it in a limited way. We have now found nuclear fusion, sir. If we do a lot of nuclear fusion, you are getting a lot of nuclear waste. If we are trying to do mining, and if we start do mining and start do a lot of mining, and you're going to, it's going to end up all bad. So we have to use it in the limited and the right way. You are using it for online classes or like this, which doesn't affect the nature. We should not affect the nature by using the science, because if we affect nature, then it's not right. We are getting from it, we cannot, it's like cheating nature. So, and it would also have many causes on us if we do cheat.
Okay. Thank you, Samanyu. That was interesting point. Anybody else would like to answer this? Then I'll. Jayant, yes, you did not have your chance. Yes, Jayant, you can talk now. Yes.
Yes, sir. Science is good and bad because if we have science, now we are connected to this online. And if we say If we do not, science is bad also because we use science for atom. We are using for bombs. So people are using atom bombs carelessly and killing people and affecting the nature.
Okay, good. Thank you, Jan. You can mute yourself. Okay, so now, anybody else? Okay, so I think some of you have typed in. Ashwin says both are good up to a point, and Jonathan Franklin says, but can land in bad hands, not gaming. I'm not able to unmute myself. That's different. Technology is good unless and until we use it for a good reason. Today's technology is good. Okay, right. Okay, I think from what I understand from all of your responses, it's like depends on who you uses it, or maybe how you use it, right? So I think that is the larger response you're giving. Yes, you are correct. Alicia says both good and bad. Again, Jonathan, I'll give you a wait, I'll unmute to ask you. Unmute. How am I going to unmute you? Okay, can you unmute now? I've requested you to unmute, Jonathan. You can talk. I can't. Are you talking?
Sir, sir,
Yes, please
actually,
talk.
science and technology both are okay for the current situation, but if it can land in the most chances, it can land in the bad people's hands only. Like they will portray in stories and all that.
Okay, okay. Science, yeah. The moment you think of science, you guys think like a mad scientist in a movie who's has evil plans to destroy the world and create an atom bomb. I think that is been getting from movies also, right? You have this bad villain who's a scientist who wants to destroy the world by bionuclear war or whatever nuclear war. I think that is also a general portrayal of science in movies also. But again, then there are good scientists as well in the movies. But you get the point. Yes. Thank you, Jonathan. Yes. Now let me ask you this question. So how many of you know this equation that I have typed in the chat box? Have you heard of that equation? Yeah, Big Horror is a good six is a good movie. Yes, no idea but heard of it. E equals mc square. Okay, who do you remember when you think of that equation? Those of you heard of it. Einstein, Albert Einstein, right? E equals mc square is one of the famous equations ever. Okay, so now those of you. Okay, just give me a moment. I have some. Just give me a moment. Okay. Am I audible, right? So if I'm not audible, please let me know. So now E is equal to mc square is one of the most famous equations ever. Now that was discovered, or rather written down by Einstein in the year 1905. 1905. Okay. 125 years ago, 115 years ago from today. Okay. So that is how old that E is equal to m square is the equation is. So now it has taken several hours and years of mind for Einstein to put and come up with this equation. Okay. So now, is this equation a good or bad equation? Yes, Jonathan, it was in Germany. Yes. All those information I think you guys have. Is E is equal to mc square a good equation or a bad equation? Very good. Yes. Anybody else? Ashwin says it's good. Okay, good. Is equals mc square a equation, a good equation or a bad equation? Okay, those of you who are struggling, even used to launch rocket, yes. So now some of you, okay, so some of you who are trying to study how the equation came about, how did Einstein come up with the equation, if you want to work on it, it might be very difficult. Some of you who are not good in mathematics may hate the equation. Oh my goodness, it's so difficult to arrive at this equation, so I don't like this equation, so this equation is bad. But that is what I'm trying to tell you. But is this equation a good equation or a bad equation? Maybe good or bad. Why, Alicia? Why are you saying it may be both good or bad? Bad because you have to learn at school, but good for practical relation. Good. So that's exactly what I was trying to say. Good. Very useful. Okay. Okay, let me see. Oh, I'm not able to see what you guys have typed. Let me come down the chat. I think I went to the beginning of the chat. I haven't tried studying it. What is the meaning of E is the MC square? Okay. So now let me tell you, okay. So now Jayant Kumar, what is the formula used for? That is a good question. So without knowing what is the formula used for, you might not be able to say whether the equation is good or bad. Okay, let me tell you. That equation E is equal to mc square is the reason why Hiroshima Nagasaki was bombed. All of you know Hiroshima and Nagasaki, that Japan were bombed in Second World War by United States of America because of Pearl Harbor. I'm sure you know of this history. Two atom bombs, little boy, the Manhattan Project. Okay, they were able to build those two big atom bombs by using this equation E is equal to mc square, or the understanding of the equation E is equal to mc square. Is it a bad equation or a good equation? Now, is it a bad equation or a good equation? Okay, okay. Now, now let me come to another point. Okay, so now for a long period of time, people did not understand how stars function. All of you know stars, right? Now some are doing nuclear fusion or something. Do you guys know how stars are able to maintain the energy and give the output energy? Do you guys know it? Helium and hydrogen. UN says people might be able to make tremendous amounts of energy from small masses. So if someone somehow could take all the from an elephant, it would be able to destroy Russia. But why would it take from elephant? Okay, interesting. You could have said a simple rock, a giant rock, but it chose an elephant. It's interesting. Okay, because of hydrogen and helium, what happens? What happens to hydrogen and helium? What happens in the star? By very good, Samanyu. Yes, Harshan, very good. I'm sure most of you know it is because of the fusion of atoms. So now people were trying to understand how does the star get much of energy, and they were trying to understand. Okay, if two atoms, let's say hydrogen or hydrogen and helium, they combine, how much amount of energy they're able to generate, and that when they calculated, they were able to calculate using the formula E is equal to mc square. They tried to use the formula E is equal to mc square to understand how much amount of energy the star is giving as output. And no, you know what? When they calculated how much of energy they were able to generate, it exactly matched with E is equal to mc square formula. It exactly matched. Whatever energy was coming outside of the star was exactly given by the equation E is equal to mc square. Now, this E is equal to mc square has opened our window into understanding nature itself. It is science. Okay, the same concept, E is equal to mc square, is the reason why millions of homes are powered using nuclear power plants. Do you guys know what nuclear power plants are? Do you guys know what nuclear power plants are? you generate you generate electricity by breaking up atoms. You generate electricity by breaking up the nucleus of an atom. So you have atoms like uranium, and there are some radioactive atoms. When you break them apart, when you break the nucleus apart, they release a lot of amount of energy. And how much of energy? How do you know? E is equal to mc square. The same energy by breaking an atom can be used to bomb Hiroshima, Nagasaki, or the same energy by breaking up an atom can be used to power a million homes. Now tell me, is E is equal to mc square a good thing or a bad thing? Is it a good equation or a bad equation? Okay, both. Both sounds to be fair. When you say both good and bad, it is a fair argument. But my contention is this. My view or my answer to the question is this: it is neither good nor bad. It is just an equation. It is just an equation. Now let us think of it like this way. Let us say you're walking on the road and you find a stone on the road, a pebble on the road. Is that pebble a good pebble? Is it possible to say whether the pebble is a good pebble or a bad pebble? It's just a pebble. How can you give it a value? How can you give it a value, good or bad? It is impossible to give a pebble a value, good or bad or both, because the same pebble you can use to strike somebody and kill somebody, or same pebble you can use it for some useful purpose that could save someone's life. I don't know how a pebble can be used to save someone's life, but you get the point. So a pebble, when you're asking the question, is the pebble good or bad? The question is irrelevant. The question does not even make sense to ask whether science is good or bad. It is just there. It's like a stone, it is there. Now the question can be, is the person who is going to use it good or bad? That can be, that is a valid question. But asking science itself whether it is good or bad, it's not, the question doesn't even make sense. So when the question doesn't even make sense, it doesn't answer at all. So that is how I view it. It is neither, it's neither good nor bad. Okay, so now this is some important, that something very important that you guys will have to remember. Whenever people say, look, science is destroying the world, science is not good, technology has destroyed the lives of people, technology is bad. No, no, technology and science has only helped us understand about nature. It has not destroyed anything. On the other hand, it is the people who use it can destroy it. Okay, so now next time I want you to remember, when people keep saying, no, technology is bad, and technology by itself is not bad. It depends on how. Okay, let me ask you this question. Is a gun, the technology of a gun, good or bad? I'm sure all of you know guns. Gun is a technology, right? The reason I say technology is because the gun operates on some scientific principle. The gun, the working of a gun operates on some scientific principle, right? So the technology of a gun, is it good or bad? Neither. It depends on someone who uses it. The soldiers and the army who are at the border defending the country, it's a good technology for them. But for the people who are killing on a mindless rampage, they go on a shooting spree, it's bad. So whether is gun a good thing or a bad thing, you cannot answer that question, right? How can I answer such a question? Again, so now it comes to the person who uses it, whether it is good or bad. So I think I've talked enough on this front. What is science? What is technology? And what is the difference between them? Is science and technology good or bad? I think I've answered on this part. Now there is only one more part that is very important. With that part, I'm going to end it. Okay. Now I'm going to ask you a question. Okay, in the equation, it is that mass of the particle is energy of the particle, right? Some of you, I'll explain about the equation a little more later, because it requires a little more understanding. But I'll give you the words of it. What E is equal to mc square means, I'll try to type it out. Just give me. I'm just typing it. I think those of you who know it can type it also. Those of you know what E is equal to mc square stands for, each of the words, each of the letters, you can type in the chat box so others can see. E equals mc square. What does it stand for? You can type in the chat box. Akshay or somebody. You can type in. In the meantime, I'll have a gulp of water. I've been talking a lot. So what is E? What is M? What is C? Nobody knows what is E, what is M, what is C. That is just sad. I'm sure Akshay, you know it. You can type it if you know, or say it, whatever it is. What is that you don't understand, Bharat? You can. Okay, don't worry, Jonathan. You're just a sixth grader, but you will know today. Okay, like Yuvan has typed energy. E stands for energy. Okay, M stands for mass, and C stands for speed of light. The speed at which the light travels. So EMC. Those are the words that stand for these letters EMC. Okay. So now coming to the last part of my session, 10 more minutes, and then you guys can ask me a question, and they'll end by 8:15. Okay. Thank you, Miru. You got it right. Now, which is important? Is science more important or technology more important? Which right, given the current scenario, I'm not talking about in general, but given the current scenario, should we invest more in science or should we invest more in technology? We know we have to invest in both are important, but do you think with which we should invest more right now in the current situation, which should be given more importance, science or technology? Whatever your explanations are, you just need me to convince me that what give me the reasons. Okay, Ashwin, you can tell me why. Okay, there are a lot of people raising hands. No. Alicia says technology. Jonathan says technology. Uh, Jan says both, but he prefers technology. Okay, can you guys give me a reason? Those of you say whether it is science or science, it's the base of technology. But then again, Miru, people who are doing it, okay, given the current situation, I know the technology is important, but right now science is of no use, right? Right now, technology is what is needed. People may ask, okay, Jonathan, unmute you. Wait, Jonathan, unmute. Yes, Jonathan. I've asked you to unmute.
Sir, for the current situation, we need both of them, sir. Otherwise, like if science is not there, then in the future we will not find out that medicine for this virus. Then 100% there,
Okay.
even we need
Good point.
technology because we have to make billions of it. So many people are affected. So we need to make billions and billions.
That is good.
So
That is
we
very
can't
good.
just use our hands. So we need to use like some machines which includes technology and science, both integrated.
Okay, that is a very good example. I loved the example. Look, finding a vaccine or understanding the virus is science, right? It is understanding the nature. What is the structure of virus, or what is it? What are the molecules it is made of? What are the proteins in the virus? So that is understanding about the virus that will help us eventually come up with a vaccine. Okay, so now that is not technology, and that is not going to save people's life. But once you understand the virus and once you know what it is made up of, then you can use technology to make it available for every single person on this planet so that they get immunity from the virus. So now that is a very good example. Can you give me similar others give me similar examples or something some other examples similar to this, not in the current situation, in general, where science has led to technology that has eventually been of great help to us? Someone new? Yes. I'm looking for something examples. Okay, I have to unmute you, is it? Okay. Someone new. I see nobody else is talking. Someone new.
Sir,
Yes.
sir, like
I can.
you told me to give the example of something like which helps science and
Correct.
makes technology that is useful, sir.
Correct.
Like
Correct.
it is like our if like Michael Faraday imagined his science made technology and the
Yeah, Michael Faraday
technology
example
made
I
use.
gave. Michael Faraday.
Oh, sorry, sir, I
Michael
did
Faraday
not hear.
example I gave. I want to give you some other example. Okay, no problem. You think on it, Jayant. Yes.
Sir, whenever we get a crisis like this, even during polio, when polio was spreading, diarrhea, cholera, all this spread, we need technology and science, because if we don't have science, we can't find a vaccine and medicine for that. And if we don't have technology, we can't get connected with each other.
Okay, good one. So now you are giving us examples of in the medical field. Great. Ashwin, yes, you can go ahead, Ashwin.
Anna, can you hear me?
I can hear you, Ashwin. Yes.
Like first we should know science, like rocket science, so that we can make rocket using technology and launch it. So we need both.
Okay, so you're saying to build a rocket, you need to understand the science. But once you understand science and the rocket is built, you can launch it and use it for some purpose. Okay, I can
Yeah,
take it like
like
this also, like in the case of also. Good. Thank you. Okay, right. Okay, Yuvan is still stuck with the E is equal to MC square. I'm glad Yuvan, but right. Okay, let us move on. Someone, I'll give you another. I'll just I like to. So now, let me tell you how science and technology not only working together help the human race or to conserve other species around. Like for example, you want to like the tiger population is dwindling, for example, or some species are like dwindling in their numbers or they're endangered. How do we know they're dwindling? You use technology to track them. You tag them, radio tag them, or use radio frequency to ID them. So there are a lot of, not just for human race, you use science and technology to save other species also, not just the human race. Okay, so now science and technology, in that regard, they can work together to save a lot of species. They can work together to save a lot different. How does science and technology help each other, not the human race? We know how it helps the human race, or we know how it helps the other species, but how do they help each other? Okay, now that I'll give you one example. Okay, now whenever we wanted to, I'll give you one example, like how many of you know planets Uranus, Neptune and Pluto? Pluto is not a planet, but nevertheless, of course, you've heard of it. Once it was a planet, now it is not a planet, it's a dwarf planet, but nevertheless, you have Uranus, Pluto and Neptune. Now until 16th century, okay, until 16th 17th century, our ancestors or people below from any civilization, not just Indians, Western civilization, whatever civilization, you will not have any mention of the planet Uranus, Neptune, or Pluto. You take any mythological stories, or you take any stories of gods, or you take any, now they have integrated. But in the old textbooks till the 17th century, you take whatever hundreds and thousands of books written by our ancestors who were so brilliant also, even them, they don't mention Uranus, Neptune or Pluto in their textures or scriptures or whatever it is. Why? They couldn't see it. It was not visible to the naked eye. Look, it is not, look, Mars or Mercury or Jupiter, it is still visible to your eye and you can say that they are there. But so there is a physical limitation. Someone knew what I was trying to say is our understanding or our discovery of the existence of planets Uranus and Neptune and Pluto came only after the discovery of a telescope, or rather the invention of a telescope. Before the telescopes were invented, people did not know that Neptune, Pluto, Uranus existed even. All they knew was 5 planets: Jupiter, Saturn, Mercury, you have Venus, and I think one planet I missed, Earth, of course, Earth itself. So they knew of only planets. Now, why did, despite the fact that our ancestors were so brilliant, they were brilliant, no doubt about it, but why couldn't they discover new science? Look, discovery of a planet is essentially new science. It's not a technology. Okay, discovery of a new planet is essentially science because it's understanding nature. Why couldn't the people back then, before the invention of a telescope, do it? Because they did not have the technology to make a new discovery in science. They did not have the technology to have. So what is the technology I'm talking about? Telescope. Telescope is a technology, it's a machine. That machine itself works on some other scientific principles. Okay, now you have some science where when I say science of a telescope, lenses, a telescope makes use of lenses, telescope makes use of mirrors, how light travels, how light falls on a lens, how does the light bend. It's all a lot of science. Using those science, you build a technology called telescope. Okay, and that technology leads to the invent or discovery of new science. So science leads to technology, and that technology leads to discovery of new things in science. So now science and technology are helping each other to move forward. Now without, this is because our humans have limitations. Look, no matter how much you want, your eyes have a limitation, right? Can you tomorrow look up at the sky and immediately look up Jupiter, look up at Pluto and see it? You can't. You can't see Pluto no matter how much powerful you want your eyes to be, because according to evolution, we have evolved to a fact that we are limited by our eye power, right? No matter what, but there are some other animals that can see farther or more fainter objects than us. But for example, night owls, They have much bigger eyes, but each animals have adapted to our own needs. Humans, we cannot see Pluto with our naked eye, and that is the reason why we were not able to find in any of the old scriptures about Pluto mention of it nowhere. It was in 1930s. So Pluto, we were able to discover it only in 1930s. Okay, Uranus we discovered in 18th century, Neptune in the 18th century, but Pluto was discovered only in the year 1930 with a huge telescope in 1930 by another scientist called Clyde Tombaugh. So that's for another time. Now, this is the point. Any new science discovery that you make will eventually lead to a technology. That technology might be useful to humans or not. Might be useful to humans, might not be useful to humans. But whether it is useful to humans or not, it might be useful to finding something completely new to us about Earth. For example, black holes. I'm sure you, since I'm into astronomy, I'm giving a lot of examples for astronomy, not to be biased against any other subjects. But black holes, until about few decades ago, people did not even know black holes existed. Now people have gone to the level of even capturing a picture of a black hole. Did you guys know? People photographed a black hole recently. Why were people not able to do earlier? They did not have the technology. They did not have the technology to have a camera that can capture the picture of a black hole. Now, by capturing the picture of a black hole, they're understanding black holes even better. So that is science. So this is something that I wanted to talk to you about, guys. I think that is enough for the day. I think I've given you a lot of things. Now the session is open to questions, but I'll give a quick recap. I talked about what is science, what is technology, what is the difference between science and technology, and is science and technology good or bad? Does it even make sense to ask that question? Now, in what sense is science and technology helping the human race and other species, and in what way that science and technology help each other? The topics that I covered, and I hope you learned something new from today's session. Now it is open to questions, and we'll take questions for about 10 minutes or so, and then we'll wind up. I'm also very hungry. I'm sure you guys must also be very hungry. I'm open to taking questions. You're welcome, Jonathan. Yes, I'm open to taking questions. I'll unmute you, Jonathan. Wait. Yes.
Sir, then one question, sir. So, like technology, we use very integrated with science most of the time. Then, like
Correct.
which one has the minor part in it? Half the time, which one has
So,
the
like I
minor
said,
part?
we like when I say minor part, Jonathan, like right now we are using the technology. We are a beneficiary of some science which has become technology. But right now, when you're using this computer, you don't think about what has gone into it, right? We are so used to computers that we don't think about like what has gone into the computer, how does something appear on the screen, and if I click on something, how is it opening, what is the display, how does the science of it work. So what has happened is we are so used to using a lot of things around us that we have started taking it for granted. We don't know, like, oh, it could be a simple fan. Okay, now we know the way the fan operates. It is very simple, right? All you need is a coil of wire and you need a magnet, and you pass current and the fan spins. A very simple concept. But when you think about it, that simple idea has taken about 300 years to materialize. Right from Michael Faraday's time, it has taken hundreds of years to see something simple like your fan spinning above your head. So that is what I want you guys to remember. Okay, now when you look at from that perspective, now is technology a major role or science a major role? Both. Right now it might look like technology has got a major role. It is like so powerful. It might look like, oh, science avlaka illa, it's not that big deal. But when you combine it with the history of how something has come about, then probably you will feel, oh, science and technology both have equal role to play in what we are experiencing right now, or what we are benefiting right now from. Okay, thank you, Ram. I think I'm glad you enjoyed. Did you guys like it? By the way, did you like the session? Do you have any feedback about this? Did you not understand any part of it? Thank you, Jonathan. I'm glad you enjoyed. And Saman, you have some questions for Saman. I'm very Saman. Yes, you raised your hand. If you have any question, you can ask.
Sir, yes, sir. First, what I have to tell is the session was really amazing, sir. And my question was that you told, sir, about the E is equal to MC2. Now, Yuvraj Anna told how to do it, sir. And if E is equal to MC squared, sir, we are using E is equal to MC squared. So if we use E is equal to MC square, the energy, and if we square it by light speed, when we are getting so much energy,
Yes.
if we
Yes.
are getting
But
so much energy,
why can't we use it for our powering our homes? Is that
yes,
why can't
sir,
we use
not
it in
only
KTM?
for, yes, sir, why can't we use it? And we also have many other ways to power like that energy, like using quantum
Yeah, I'll tell
fluctuation
you,
or
Samanu.
more.
Samanu, okay, I'll tell you the answer. The problem is, it is not easy to look. E is equal to MC square looks easy on a piece of paper. It's just three letters, E, M, C, and one of the letters you are squaring it. It's a very simple equation. It is like A is equal to B into C. Okay, but in reality, to convert something into energy, it is very difficult. It is not possible, like under normal conditions, to do that. You need a very big setup. Under controlled conditions you can do it, but the stars are able to do it because stars are so massive. Stars are easily able to do that E is equal to MC square process. But humans, it is not that all the materials. Let's say I have a phone, or let's say I have this laptop. I cannot convert this laptop into a huge amount of energy suddenly if I wanted to, because not all the atoms it is possible to convert it just like that. You need certain conditions. Only certain kind of atoms that can be used for converting into energy, and those are the kind of atoms that are being used in nuclear power plants. For example, I gave you uranium atoms or plutonium atoms. Those kind of atoms can undergo easily the conversion of energy, mass into energy. Yes, Harshan. Yes, Harshan. Somebody will come to you. Harshan. Yes, Harshan. Harshan, can you hear me? I asked you to unmute. You can unmute and talk. Thank you, guys. Thank you. I'm glad you all liked it. Harshan, you have something to ask, but I'm not able to hear you. Okay, maybe I'll connect you through the Discord app. Anyway, we have a channel and a club. We can get connected there. Harshan, don't worry. I can't hear you. Can you give more example of science and technology? Uh, okay. How the GPS technology, for example. I'm sure uh, you guys heard of GPS, right? You guys know how it works. So the entire GPS, the technology works on a simple scientific principle of radio waves, the light, radio communication. Receiver, Murray, you have signals that you can send and receive, and that technology is used in the GPS technology. And that GPS technology is being used like everywhere. Your Google Maps or your Uber, Ola, your Swiggy. There are entire companies that run on GPS technology. Like certain companies cannot exist if not for GPS. Do you think Ola, Uber, or Swiggy will survive as a company if not for GPS technology? If GPS is not there, do you think these are like the thousands of crores companies? They earn thousands of crores depends on GPS technology. That one technology is helping them earn millions of dollars. So how did that GPS technology come into picture? Because by understanding how light works, how radio waves work, that understanding that basic scientific discovery has helped us build GPS technology, and that is being used by the entire human race. Okay, not just the human race, but to save other species also. There are satellite tracking of species. For example, there are whales or there are leopards and tigers who they tag. They have radio tag, and they are monitored using satellites. They can track how these species move in the forest or move in the water. So you have multiple uses. Yes, yes, Harshan. triangulation, correct. Okay, guys, I also enjoy talking with you. I will catch you again with another interesting session we can have on some specific science topic. Until then, thank you. If you guys want to say thank you and bye to each other, you can